In this video, we're going to look at factorising expressions which have 4 terms in them. These are often similar to quadratics, but they look a little bit different because they're not just in one letter normally. So let's jump into some examples. xy minus 5y minus 2x plus 10. Now when we look at this, there's nothing that jumps out at us that factorises into every term, so we can't factorise out one thing from all of the terms, and it doesn't look like a quadratic to factorise into 2 brackets. But what we can do is factorise this into 2 brackets, and there's 2 methods to do this. The first one on the left is going to be the sort of intuitive approach, and that is, if we think we've got 2 brackets, we've got to multiply 2 things to get xy. So we've got to have x times y. We've also got to multiply the y to get minus 5. So we must have minus 5 here. And we need to multiply the x by minus 2, so we must have minus 2 here. If we were to now consider multiplying this out, we get xy minus 2x minus 5y, and the final one is the minus 5 times the minus 2 does indeed give us the plus 10. So one way to look at it is to just think, what do we need to multiply, and then pair things up until you get something that works. Sometimes that can be quite tricky to do though, so we have another method that always works. And the way we do this is we factorise by grouping. So we start off by looking just at the first 2 parts of this, and we notice that that factorises to y x minus 5. And then we look at the second 2 parts, and we notice that that factorises to minus 2 brackets, well, x, and what do we have to times minus 2 by to get plus 10? Well, it's minus 5. Now we notice that we have 2 expressions that have an x minus 5 as part of them. And what we can then do is take the remaining bits, that's this y at the front and this minus 2 at the front, and make a second bracket out of them. Y minus 2 and then x minus 5, giving us the same answer as we got with the intuitive approach. The reason this works is we're factorising out the x minus 5 from both parts after the initial factorisation. So let's look at another example. ab minus 2a plus 3b minus 6. So it's a 4 term with nothing obvious to factorise out, so we're thinking it's going to be into 2 brackets. To get ab, we need an a and a b. To get minus 2a, we need a minus 2 over here. And to get plus 3b, we need a plus 3 here. If we just quickly check, we get ab minus 2a plus 3b and then minus 6. So that is correct. Looking at the other method, we first of all factorise the first pair, and we can see that a comes out of that, leaving us with b minus 2. Then we factorise the second pair. We can factorise a plus 3 out of that, leaving us with a b minus 2 as well. And now that we have the same bracket in both parts, we can factorise out all of it. So we get a plus 3, that bit and that bit, inside one bracket, and the b minus 2 in the second bracket. One final example. Here we've got, that should say x squared there. Here we've got x squared plus 3x plus yx plus 3y. And we're going to do the same thing. We're going to try and put it into 2 brackets because it looks a bit like a quadratic. To get x squared, we need an x and an x. To get a plus 3x, we need a plus 3 in one bracket. To get a plus yx, we need a plus y in the other bracket. And now if we check, we get x squared plus 3x plus yx plus 3y. So that does indeed give us what we want. And trying with the other method, the grouping method, first of all we have x squared plus 3x, so we can factorize out of that x, and we get x plus 3. Then we get yx plus 3y, we can factorize out of that a y, and we get x plus 3. Now that we've got x plus 3, the same bracket in both groupings, we can factorize to x plus y, the two bits that are outside the brackets, times by x plus 3, the brackets that match up. So that's how we factorize 4-term expressions.